Hi, Janisha. So this is the homework question that you sent me. It's problem number 2 on homework number 6. I'm going to copy this triangle over onto OneNote so that I can help you work it out. It looks like they've given us 2 side lengths. We've got a side length of 31 and 23, and they've given us one angle measure of 35.2 degrees. So let me get this copied over. So that's how they've got their angles labeled. Make sure that you're always labeling your sides with the exact same letter directly across from the same angle. So if angle A is here, we're going to do side A over here, and angle B is here, so side B is here. Angle C is here, so side C is here. And then let's put the values. So angle A is 35.2 degrees. And then it looks like side B is 31. And side A is 23. And we want to solve the triangle. So because we have a side angle pair, we've got both of our A's, we can use law of sines. Anytime you have a side angle pair, you can use law of sines. And we learn about law of sines in section 1. Law of cosines is when you don't have any side angle pairs. So like if they gave you angle A and then side B and side C. So those are 3 different letters. So you don't have any side angle pairs. So then you'd have to use law of cosines. But because we have both of our A's, we can use law of sines. So the law of sines says that side A over the sine of angle A, that the value for that fraction is going to be the same no matter which side angle pair you put in the fraction. So it's the same for the A's, the B's, and the C's. So even though there's 3 fractions there, we really only use 2 at a time. And we know both of our A's, so we're definitely going to use the A's. And right now we know little b. So we're also going to use this one, and we're going to be able to solve for angle b. So we know little a, we know big A, we know little b. So we can set up the a and b fractions and solve for angle b. So make sure your calculator is in degree mode, because so far the angle they have given us is in degrees. And if you look at the answer boxes, there's a little degree symbol after them. So we want to make sure that we're in degree mode. And we're going to set up these 2 fractions with an equal between and plug in everything that we know so far. So we know that side A is 23. Angle A is 35.2 degrees. Side B is 31. And we don't know angle B. That's the one unknown in this equation. And we want to solve this equation for angle B. So I'm going to start off by cross multiplying. And when I do that, I get 23 times the sine of B equals 31 times the sine of 35.2 degrees. So that gets rid of the fractions for us. And we're trying to solve for the sine of, or we're trying to solve for angle B. We're trying to isolate B. So there's two things that we need to do to get B all by itself. First of all, we need to divide the 23 over because it's 23 times the sine of B. So we divide our 23 over, and I haven't typed any of this into the calculator yet, and that's really important because we don't want to round anything until the very end. So now I've got the sine of B is 31 times the sine of 35.2 degrees all over 23. So the sine of angle B is this big fraction value. So to find angle B, I now need to move the sine function over to the other side. And the way that we move trig functions is by doing inverse trig. So angle B is sine inverse of all of this stuff. So I can type this whole thing into my calculator, sine inverse of 31 sine 35.2 degrees all over 23. Make sure that you close this parenthesis on your angle before you hit divide by 23, because when you hit sine on your calculator, it's going to open a parenthesis. So just make sure you close that because we want the entire thing divided by 23. And then again, make sure your calculator is in degree mode. Hold on one second, I'm going to grab my calculator. So when I do this, I'm going to go back to MyLabs Plus, and they want round degree measures to the nearest tenth as needed. My calculator right now says that angle B is 50.98038889 degrees. And we need to round that to the nearest tenth. You need to round that to the nearest tenth. So to round to the nearest tenth, we look at our hundredths position. And if our hundredths position is greater than 5, that means this number is going to get rounded up. So technically, since this goes up, it's going to go up to 0, and this is going to go up to 1. So B is 51 degrees. Now, some of these problems could potentially have two answers, and we need to check if this is the case. It could have two answers if this is just the reference angle. If this is the reference angle, that means B is technically an angle between 90 and 180, and we need to subtract this number from 180 to get the answer. So another option, so this might be option number 1. So option number 2 is that they just gave us the reference angle. Option number 2 is that B is 180 minus this number. And if that's the case, 180 minus 51 is 129. So there might be two answers to this one. The way that we know there might be two answers is based on what sort of information was given to us in the triangle. And triangle problems are classified by what information was given. So we were given an angle, so I call that A. And then work your way around the triangle. We were given a side and a side. So I know this is going to sound kind of silly, but it's a good way to remember. This is an angle side side triangle problem. So yes, that spells a bad word. This is an ash triangle. Those are the bad triangles. Those are the ones that are going to give you trouble. Those are the ones that could possibly have two answers. Anytime you're given a triangle where they gave you angle side side all in a row, there could be two answers. Angle side side. Now if they gave us angle side angle, that doesn't spell a bad word, so there's not going to be two answers. Or if they gave us side angle side, that's not a problem. It's not going to have two answers. They gave us angle side side. Bad word, bad problem, two possible answers. So right now we have two possible answers. B is 51, we got from the calculator. It's also possible that that's a reference angle, because remember, sine can be positive in quadrant 1 and quadrant 2. So it could be the calculator gave us back a reference angle and we have to subtract it from 180, and it could be that B is 129. Now we should check and see if that's a reasonable answer. And the way that I know it's a reasonable answer is I look on my triangle. I would say, well, is it possible that that's 129 degrees? If that's 129 degrees, that's a really big angle. There should be a pretty long side across from it, and 31 is a long side. When we fill C in, it will make more sense. So let's look for our C's also. So let me recap what we know so far. In both of these cases, we know that A is, what did we say A was? 35.2. So we've got two different problems going on here now. It has all of a sudden split into two problems. So for both of these, we need to see what now is left over for angle C, because every triangle is going to have three angles that add up to 180. So for option number 1, so far, we've got 51 and 35.2. We need to see what else is left over for C to make 180 degrees. So we'll subtract 51 and 35.2 from 180 to see what's left. And I get 93.8. And then for option number 2, we've got B is 129, A is 35.2, and we'll subtract those from 180 and see what's left. And here, we've only got 15.8. We also know a couple of the sides. We know that side A is 23 and side B is 31. So the only thing we're missing right now to finish this problem is side C. Only thing we're missing is side C. So we're going to do law of sines one more time. You cannot do the Pythagorean theorem here. Pythagorean theorem is only for right triangles. And this is not a right triangle. A right triangle would have a 90-degree corner, a perfect 90-degree corner, and this one does not. So our only other option is to do law of sines again. So this time, since we're trying to solve for c, we're going to do law of sines with the c fraction. And I'm not going to use the b's because b, when we b was an estimated value. B was a value from the calculator. What I want to do is I want to go back and use the a's again because the a's were given and the a's are exact values. So this time I'm going to set a fraction up between the a's and the c's. So I'm going to go through law of sines one more time, this time between the a's and the c's. So I'm going to say a over sine of a equals c over sine of c. We're going to have to do it twice though because we've now figured out two triangles that this could possibly work for. So for my first option, a is 23 and angle A was 35.2. We don't know little c, but we did say angle C was 93.8. And we're going to cross multiply. And we get c times the sine of 35.2 equals 23 times the sine of 93.8. And to solve for c, we just have to divide over sine of 35.2. And you can type that whole thing in the calculator at once. Just make sure you close these parentheses after your angles. So for triangle number 1, when you type in your side lengths, they want sides, round side measures to the nearest integer. So the nearest whole number for side lengths. So C on my first triangle is going to be 23 sine of 93.8 divided by sine of 35.2. My calculator is saying 39.81288. My Labs Plus wants it rounded to the nearest whole number, so we're going to say 40. And then there's another option for this triangle where C is really small, so we need to do this again. So 23 over sine of 35.2 equals little c over sine of, remember we said c could also, it's possible that the b they gave us was a reference angle. We subtract it from 180, makes it b really big, and that made c really small, 15.8. And we want to solve this for little c. Cross multiply. C times the sine of 35.2 equals 23 times the sine of 15.8. And to solve for c, we just have to divide over that sine of 35.2. So when I do this, 23 times the sine of 15.8 divided by the sine of 35.2, my calculator comes out with 10.864147, on and on and on. My Labs Plus wants it rounded to the nearest whole number, so we say 11. So there are two triangles that are possible. If C ends up pretty big at 93.8, it's going to correspond to a longer side. But if C ends up much, much smaller, it's going to correspond to a much shorter side of 11. And this all depends on angle B. When we solved for angle B, since sine could technically be positive in quadrant 1 and quadrant 2, the calculator could have given us back a reference angle, and we need to take that into account. So it could be 51, or it could be 129. Either one of those will work. So this triangle has two options. And the best way to remember that is this is an angle, side, side triangle. The information they gave you was one angle, one side, in that order. And it spells a bad word. That means this is the bad triangle that has two options. It's the ASS triangle. So anytime you see a triangle where they give you angle, side, side, you should try to do two answers. The very first angle you solve for, take the answer the calculator gave you, but also work out a second problem where you subtract that angle from 180. Now, it's possible that when you subtract the angle from 180, there's nothing left for C. If that's the case, then you can forget about option number 2. But in our case, there was some left for C, so we do have an option number 2. So we do have to go through the whole thing, and this one has two options. So we've got all of our info here. We need to go back to MyLabs Plus and say that there are two possible solutions for this triangle, and make sure we keep all of our numbers together. In this first row, you're going to put one of them. They want the measures that have the longer side of C first. So angle B, angle C, and side C with the longer C first. So the longer C is going to be the first one. It's going to be the one with the smaller B, the bigger angle C, and the bigger angle C is going to have the bigger side C. So that's the set of answers they want first. And then the set of answers they want second, it says the measurements for the solution with the shorter side C are going to go second. So a shorter side C is going to correspond to a smaller angle C. And the reason we got a smaller angle C is because angle B is so big. So that is your second set of answers. So yes, these are very tricky. So if this is the only one you ended up having trouble with, then that's awesome. These are very, very tricky when you can have two possible solutions to a triangle. So I hope that helped. It only happens with the ASS triangles, the ASS triangles. You don't have to worry about it with any of the other ones. And your calculator will give you one set of solutions, and then to get the other set of solutions, you just take that first angle answer you get and you subtract it from 180, and then just work it out like a second problem.